the delta H if you had a whole mole, but not if you had 0.1204 grams. Okay?
Okay.
I'll be quite honest, most of the problems you work are going to be more like this. On that quiz, you had one like this. On the paper you just worked, it was like the one on the top. I will switch back to that. Alright, so we started off with a balanced equation. You have blank 763. My delta T was 5.01 degrees Celsius. My delta H is C sub P times delta T. So here's kilojoules. And then all I had to do is figure out per mole and divide it by moles and get my final answer. So this one is just like question number 1 that we had. Now, my morning students feel like this is probably, of all the problems in the chapter, they feel like bomb calorimetry are the hardest and they're the ones that they need more practice. So what I'm going to try to do in the next couple of days is put together some more problems with answers. So if you struggle with this, you can work some of these. Okay? For the most part, I think everybody feels okay about Hess's law.
Yep.
We worked one more today. We can work one more if you'd like to see one more.
Yep.
But they felt like Hess's law was good. They felt okay with the products minus reactants. They felt good with the ones that were at the very beginning of the chapter. I'm talking about like the ones on page 4. We did these at the end of the chapter, but they're really, it's that idea of using the delta H as a conversion factor. These two problems are very similar to like 7, 8, and 9 on those multiple choice homework questions that you're turning in. Those are very similar. We use this idea, converting grams into moles and using the delta H when we're doing calorimetry. We use this idea. They felt like these aren't bad. My morning class felt like the bomb calorimeter problems are the ones that they're still struggling with. I don't know. What do you guys think?
Bomb calorimeter.
They're all too easy and wasting your time.
I had the most problem with.
I mean, that's one extreme.
Oh, no.
You have
The most problem I had was making a balanced equation.
okay. So you're struggling with.
I forgot everything from last year.
Writing it or finishing it or actually.
Oh no! Once I got what I needed to put in there, I could do it. It was just
So
yeah.
You're still struggling with knowing what the products are going to be.
No, I knew that. I forgot. I forgot to add the O2.
Ah. I literally said it. Or was that after you had it?
Well,
Or you were
the only way I
taking
can figure it out is if I looked at Job's. So
So if Job's wrong, you're both wrong?
I don't think I'm wrong. It makes
I don't think
sense.
I'm wrong. Job's
Oh
right.
no, I got that.
Yeah.
The same.
Yes, question.
I feel really stupid, but how do you know if it's negative or positive?
That is not a stupid question. That's a very good question. Because
Stupid.
commotion are going to be exothermic reactions. So on like, if I said I'm putting a salt in water, you don't know if it's positive or negative by looking at the delta T. But in bomb calorimetry, it has to be combustion. It's got to be exothermic. And so I don't even put anything up here. And nothing is negative until I get to the final answer.
Okay.
That's how I work thermo problems. I don't mess with like MS delta T, C delta T. I don't ever put negatives anywhere until I get to the very bottom. It just gets in the way, I think.
And then
Now,
you'll know.
again, if you were to do the exact same problem in physics, Miss Emma or whoever might treat it differently. This is the way I approach thermo problems. I don't mess with the sign till the end. Okay? So I think Hess's law is probably the easier of the problems in the chapter. I think these are the hardest problems in the chapter.
Yeah.
Okay? That's just me personally. All right, let's look at another question. Look on page, let's see, page 200, I think. I was from this morning. I'm guessing a number here. Page 200, let's look at problem
200.
It's the same one.
63. I'm on page 200 of the AP chemistry book.
What is this?
Bottom left-hand corner. Calculate the enthalpy change for the reaction P406 plus 202 makes P4010. Given the following information.
Man, you're good. Got you canceled
200.
Page 200.
All right.
Yes, problem 63. Alright,
First book.
ignoring the fact right above it tells us the section number, do you recognize that that has to be a Hess's law question? You are asked to find the delta H for one reaction given In other words, this is what we're looking for. It says find the delta H for this reaction if you are given these two other reactions. So we have P4 plus 3O2 makes P4O6. And the delta H for that is negative 1640.1. And the second reaction is P4 plus 5O2 makes P4O10 negative 2940.1 kilojoules. And so we want to find the delta H for the top reaction. It's nicer, there's only two reactions. So the only thing you can do is flip one of them, flip two of them, or something.
Mm-hmm.
Okay? So this has to be a Hess's law because you're not given heat of formations. Now, if I could look up the heat of formation of P4O6 and P4O10, which I don't think are in the back, but I'll look while you guys are solving this problem. So this is a Hess's law problem. I'm not going to use the word easy, but it is a low stress problem for a Monday.
Yes.
Those are always good.
Good choices.
I had the most trouble with these.
Yeah, I do too.
Really?
These are harder than the other ones.
No way. This makes sense. I just think
We're
about
actually
algebra.
going to solve this both ways.
It's pretty
Okay.
easy.
So let's talk about Hess's law first. See if I can not flip up my chair. All right, Hess's law.
Oh, that
I
was
told her
bad.
to talk about that and she just laughed. She said, they didn't even laugh? I said, no, they were just so shocked they didn't know what to do. Okay,
Should we have left?
no, but it was just, Bill in the front row there were like,
We laughed.
Red's mouth was like,
We laughed
didn't know what to
after
do.
the fact.
After the fact that I was laughing, you knew I wasn't hurt. I'm the one who
You guys
gets
know
hurt going up
that's
the
what
steps, that's me. Okay, so, first of all, I know this is Hess's law because they don't give me heat of formation values. They give me the heat delta H of these two, and what they're saying is manipulate these to turn into this. There's only basically two things you can do. You can flip a reaction around to move something from the right to the left. If you do that, you change the sign of the reaction. And the only thing else you can do is multiply the reaction by some factor, a whole number, 2, 3, 4, 5, or a fraction, half, a third, whatever. Okay? I tend to not use fractions. I will double something before I have something else. Okay? So when I look at this equation, guys, there's two things I'm looking at. I'm looking at the P4O6 and the P4O10. The oxygen's going to work its way out. It's going to cancel out. Andrew,
Sorry, I'm
honey, this
listening.
is for you.
I know I'm listening.
Okay.
I'm listening.
You're over there like,
I was punching Joe in the
I'm just
spine.
going to leave that alone. Well, it appeared to me you were like over there rubbing his back. or
No, it was
something.
my knuckles, and I was hitting him in the spine. And then I said death.
Okay.
Yeah.
All right,
Yeah,
so
you
instead
were-
of assaulting Joe, can we talk about Hess's law?
He's a robot. His feelings don't matter.
Sexually assaulting Joe. Joe's turning red now. All right,
Yep.
sorry, Joe. All right, so P4O6, so what's that? No,
Being
I know
allergic to
you're
himself.
not much of a blind, but still, you don't block their view very well. P4O6, P4O10. All right, so reaction 1, reaction 2. I need P4O6 on the right-hand side.
So you flip it.
Excuse me, on the left-hand side up here. I have it on the right-hand side, so I got to flip it over. So I'm going to bring it down, and I'm going to put P4O6 on that side. I'm going to put P4 and O2 on this side. When I do that, I make that positive 1640.1. So I've used reaction 1. Does it matter if I do reaction 1 first or reaction 2 first?
No.
No, it's irrelevant. Now sometimes when you have 3 reactions, one of them is not really needed but to cancel everything else out. Or if you have something in 2 reactions, P4O6, P4O6, you may have to wait to do that one later. Alright, so we need P4O10 as a product. It is a product. I need 1, I have 1. I'm just going to break it down like it's written. I have P4O10. I have P4 plus 5O2. I'm going to bring it down, negative 2940.1. So at this point, what cancels?
The
P4.
O's.
So P4s, okay,
3 O's.
and 3 oxygens cancel, leaving me 2 on that side. 3 goes away, leaving me 2 left. So I have 2 O2s plus P4O6 makes P4O10. Hess's law says add them together. So we have positive 1640 and negative 29, so we're going to get negative something. Negative 2940.1 plus positive 1640.1, negative 1300? Thank you.
At the unit, or
Actually, I could probably put a 0 up in there because I'm adding and subtracting.
1,300?
Yeah,
That's
29.
not 5. That's a 9. That's 29, not 25.
Oh, 29.
I thought it was 25.
me too.
Me
But
too.
then,
There you go.
oh, that was
Alright.
missing. Okay.
Now, that one's a pretty easy one because you only had 2 reactions to manipulate.
At the
And you
be-
really only had to do something to one of them. You didn't have to double anything or half anything. Now, let's do this a different way. Let's take the same equation, the P4O2, P4010. Yes, sir.
Let's
at
do
the
60.
beginning, you said we know it's Hess's law to use Hess's law because we don't have the heat of formation values.
Correct. In other words, I don't have the delta H of formation for P4010. So this is.
What are
we were
these
solving
values?
this using Hess's law. Now, let's say.
Well,
they
but what are
didn't
these
give us
values?
that.
What are the negative 1640 and the negative?
Okay, these are the heats of reaction for that reaction as it occurs.
Okay.
Okay, now, what we're gonna do is we're gonna take the same equation, only this time, we're not gonna give you the other two equations. We're gonna use heat of formation values. These are the ones that are at the back of your book, on page some of you have sticky notes because you put sticky tabs in some of the books last year, and some of you didn't. I'm on page 1058, or 59, excuse me, 1059, this table in the back. Let's do the same thing. Let's compare these two numbers and see how one compares to the other. So I'm going to be looking for, this is what we're going to do. We're going to say that the delta H of the whole reaction is the delta H of the products minus the delta H of the reactants. So I'm going to take 1 P4O10 minus P4O6 plus 2O2. Products minus reactants. And I'm going to look up their heat of formation values in the back of the book, subtract the the reactants from the products, and get a delta H. And we're going to compare this delta H to this delta H and see how close they are. Because technically, Hess's law is an estimate. Okay, so we're going to do it both ways. All right, so first of all, P4O10 is probably under the P's, but it could be under the O's. I'm never surprised sometimes. P4O10, I'm on page 1061. Look for the delta H of formation value. So that's negative 2940.1 minus P4O6, which is negative 1640, plus 2 times oxygen. Oxygen is a gas. What should its number be? 0. So technically I can take that out. So negative 2940.1 minus negative 1640.1. Let's see what we get.
Same number.
Should be the same number. Negative 2940.1.
But it does.
1640.1. Lo and behold, same answer.
It's so weird.
Sometimes you'll get an answer that's close but not exact.
Not weird.
So we solve for the heat of reaction. Heat of combustion is the same thing, guys. Heat of reaction, heat of combustion is the same heat. 2 different ways and got the same answer,
Except the second way was faster.
depending on the data they give you,
Right.
isn't it?
Mhm.
Yeah. Personally, Joe, I'd rather work it this way. Hess's law. I think these, to me personally, are easier. Some people think these are easier. The only
I think the
place
first
you can
one is
really
easier.
mess up on this is either to be in the wrong column or the wrong row, or forget to flip the products minus the reactants and do the reactants minus the products. You're going to get the same numerical answer, aren't you?
Yeah.
Just the wrong sign.
That stinks.
It does stink, especially if this is a show me your work problem
You circle
and you start up at the top with mistakes. All right. So we worked the same problem 2 different ways. We did it as products minus reactants. We did it as Hess's law. Pretty much we've done everything in this chapter. We've talked about Hess's law. We've done the stoichiometry kind of problems similar to this. Okay. Are there any questions on these? You guys still have your notes, so you're welcome to pull them out at any time and we can talk about these. But these are like 7 and 9 on your homework.
Since we're done with the chapter, when are we having a test?
Not till we finish at 19. It's the chapter test will be like 19. So
Okay.
the very earliest it would be this Friday, and it's not going to be Friday. Because
Next week.
my morning class, we didn't, Somehow they're behind you guys a little bit, and so,
They're dumb.
Good work, fast.
and their average is 10% higher.
They're dumb.
That class
Hey.
is dumb.
This, I'm just saying, their test average was a lot higher. Okay, so look at your notes, guys. Do you have any questions over either of these problems? Going for grams of something using the delta H. There's two different kinds of delta H's here.
But I don't remember working.
No questions.
No.
Okay. Because this first one over here, it's just 890 kilojoules, which means you have to do the stoichiometry. The second problem is like the two on your homework, 7 and 9. They did the stoichiometry for you because they gave you per mole. It's already been included. The 3, the 5, the 2, the 4, the whatever has already been included in the number. Yes?
Is it possible to perform a reaction calculation using kilojoules per gram?
Yes.
Okay.
Because on that quiz, I gave you the delta H as in kilojoules per gram. And as I was working it, when you guys were working, I was like, oh, I don't know the molar mass because I don't know. And I gotta give them the molar mass. I realized, no, it's per gram. You didn't need the molar mass anyways.
Okay, cool.
That's what it was in that quiz. Good question.
Thank you.
All right. Then we talked about MS delta T.
Yep.
Sometimes we have to correct the calorimeter, sometimes we don't. Like on your homework questions, let's see, like 10, 11, 12, 13. None of them asked you to correct for the calorimeter. We worked one in class, we worked a couple of them in class where you did have to correct for the calorimeter. There was one on the quiz, you had the KDR. That was just like the lab we did. And the very last part of the chapter was products, minus reactions, and Hess's law. So we're done with this chapter. Are there any kinds of questions that you need to see worked?
No, just those practice ones you said you were going to make.
Oh, some more bomb calorimeter?
Yes.
Is there anything other than bomb calorimeter problems that anyone, I mean, I can make some that are just bomb calorimeter problems and put some answers. And then I can make another worksheet with other kinds of problems. Or I can make, I mean, it doesn't matter to me. I just have to find problems from the books. Then I have to work them out so you can check your work.
Some hardcore Hess's law.
Okay, some more challenging Hess's law? Okay, not easy ones, but some that are gonna make you scratch your head and think.
Something you would put on the test.
Okay.
Something you'd put on the test. And not be on the.
Okay, so you wanna see, no, these will probably just be optional, because it's up to you.
I don't
Yeah,
care if I have
Okay, so you want
20%
some a few challenging Hess's law, questions, and you want a few more bomb calorimeter problems. Is there anything else, anybody?
Calculate for calorimeter.
Or if we have an earthquake.
Ruins the.
Yeah, like calculate for calorimeter.
The calorimeter constant?
Like,
Oh, you mean what we're correcting for them?
The contour of the
Correcting-
face cone.
Those are actually hard to find. What I found from book to book is of all the college books I have, very few of them correct for the calorimeter.
really?
But I know that I was tutoring a girl at OSU last semester, and their lab, they had to do that. Okay, so you want some where you correct for calorimeter. Okay.
You lifted it with the screen, just still sitting there.
All right, let's work another problem.
All right. No. Oh, what they're doing. More bomb calorimetry.
Chad
What kind of problem do you work right now?
dumb.
This another problem?
Yeah.
All right, let me see if I can make this bigger.
Have anything else to say?
Can I go to the restroom while you write down
That is
the
all
situation?
done
I don't need to write all
Wait,
this.
now
I
he's
already
right.
have it
So.
all worked out.
That's
Wait.
the one we just did.
Oh, that's the one we just
Nope.
did.
This says the heat of combustion for sucrose.
Sucrose.
I was waiting for the last one.
Hey, the delta, hurry up. The delta H of combustion, the heat of reaction, heat of combustion is the same thing. Heat of combustion is a more specific way to say heat of reaction. I want you to write a balanced equation for the combustion of sucrose. When you get done, you're going to end up with water. We're going to assume it's liquid.
Is that
How would that
O11?
change it? Would it?
Well, if it were a gas, yes, it is going to change B. It's going to give us a slightly
Oh,
different answer.
okay.
Is that
But
O11?
not for 8. Yes.
It's C12H22O11. So sucrose is C12H22O11. Write a balanced equation for the combustion of sucrose, and then I want you to calculate the heat of formation for the sucrose. Because you know delta H of reaction. Start off the balanced equation.
Can we just do this on the same paper?
Do we have to turn these in?
I'm not sure yet. You might. You might not.
Oh, so this is mixing like the two problems. This is Hess's law and normal.
Yeah.
This is not a Hess's law.
At the
I
bottom.
gave you heat of formation values.
Yeah, Bo.
I looked them up in the back of the book for you.
It's the anti-Hess.
Oh, that's a B. Okay.
C12,
English letters,
H22.
I thought it was a 6. So I was like, it's
Where?
Was that 011?
Algebra. Yes.
I need 11 and those. 11 and those. 12 and those. Done.
I win.
Blank 12, 11, 12. No, blank 12, 12, 11. Blank 12, 12, 11.
We wrote them backwards. It doesn't matter.
Oh.
CO2 plus H2O is the same thing as H2O plus CO2.
I did it. I did it. You're smart.
Oh, 12, 11. Noah would not high-five me. It's the diagonal. It's aliens brainwashed. I know. You've been discovered.
B.
What? I'm sorry, what'd you say? Yep, why? Oh, okay. Good to know. I was wondering about that. I was like, I wonder if Noah's ahead of me. No.
Does somebody hear a high-pitched noise?
Before I forget. I don't understand.
Who's Ryan?
Ryan is my best friend in the whole my youth leader.
Bennett?
Yes. You will have theology class. Jeremy Redmond. What? Awesome. Jeremy Redmond is going to teach us theology. Noah, stop. What? That's not a joke. It's a video. 23 minutes. I can zoom in the video. I can zoom that video. I don't know, you're short. I don't know how to do this.
Job,
Do what?
Job, you better delete your 23-minute long.
No, you better be quiet.
Well, it's not Hess's
Six
law,
gets
so,
I know.
Oh, I expect you.
and
I got A.
All I do is this.
I know. Everyone knows what that means.
so,
Are you supposed to Facebook?
is it an MSLT
On
problem?
YouTube.
No.
No, okay, that doesn't make sense.
What?
So the information they've given you is going to be like the problems 17 and 20 on your homework. This is a products minus reactants problem.
I don't want to
Yep.
be filmed.
Well, then get out of the way. There's 2 for a table.
Homework?
No, you're not. Okay, so,
How he's not even on part B.
I am on part B.
You haven't written anything.
all right, so we have a part A
That
then.
doesn't mean I'm not on part B.
We have a
Okay.
balanced equation.
Yeah,
Wait,
Job.
I'll be
Yeah,
back and we'll
what?
catch you. Blank 12,
We have
12,
already
11.
done.
Don't judge Noah because of his stupidity. Don't judge Noah by his cover.
What is B's
Yes, that's
question?
what I got.
Calculate heat?
So here's what we're doing.
Formation, which is
The delta H of the entire reaction is the delta H of the products minus the delta H of the reactants. So the equation, that equation's on your purple sheet. But here's the trick to this question. You have the delta H of reaction.
That makes sense.
You have the negative 5639. They gave you the heat of reaction. You're looking for the heat of formation for this. So technically this is X or Z or Y or whatever you want to call your favorite algebraic letter. This is what you're looking for. Guys, this is tricky. You have to understand, it's like the bomb calorimeter problems. You have to understand what you're solving for. This is tricky because they gave you the heat of the whole reaction, and we're going to do products minus reactants, only this is going to be a 0, so technically this whole term is X now. This is different. You haven't seen one of these.
Yep.
Now solve it. Here are the heat of formation values up here, so you didn't have to look them up in your book.
Wait, how can you take out the 0?
How do you know X?
Why can I? Because oxygen is already in its standard combined state.
Brilliant.
Oh.
It's a 0. Kind of like question number 18 on your homework.
Yep.
It's already in its
Just like that one.
standard state, so it takes no energy to make it. Therefore, it's just a 0.
So, I did get this 5014. Is it 5014.2?
It should be a bigger number.
It should be bigger.
No, mine is smaller. Never mind. Wait, yeah, bigger. It should be bigger.
I don't think so.
I think so. Because there's a negative on the X.
How do you know the heat of
You have
formation
12 times
for this?
negative 400,
Huh?
basically. 11 times negative 300.
11 times.
That's a pretty good number.
What? How'd you get that? Oh. Yeah, okay. Dumb. I'm dumb.
Is it negative 2,221?
Yeah.
It should be positive.
No, it should not.
Yeah, no, I got the same mix up, but it has to be negative because it's a combustion.
But you end up with negative X, so you have
Yeah.
to,
So it becomes positive.
What? But it's a combustion.
when you add this to this side, you get positive 2,000, right? Roughly?
No,
Yeah.
Negative 7,800. If you add it to this side,
I
which
didn't.
gives you positive 2,000, and you get negative X, you move the X or the negative over, so X leaves positive. Unless I'm doing my algebra backwards.
No, it has to be because it's a combustion.
That's it.
I thought about that. I'm like,
But does it times?
Because when you add 7860 to this side, you get positive something equals negative X, and I was told you have to change the negative X to positive X by multiplying by negative 1.
Well, if it's a positive 5,000 plus a negative
What do you mean
7,
it's positive 5,000?
well, the problem gave it to us as a positive number.
It's
didn't.
Negative
exothermic,
double time.
it's negative.
It's a negative.
At the top it said negative?
I
No,
didn't.
it didn't say negative, but it is, it's
It's
a combustion
combustion,
reaction. It
yeah.
had to be negative delta H.
Oh, well, I had it as positive and I still got
Yeah.
negative.
That should be negative, which means this is negative.
Can you scroll down?
Well, then it
Move the
should be a
paper.
positive number, shouldn't it?
No.
Because if you're adding,
Oh, well, the heat of formation, back to what Rhett was saying. The heat of formation value, since we're looking for this could be positive or negative. This has to be negative. I just got lazy and didn't put my negative on the top. I shouldn't have, you won't always be told it's negative 56,000 or 5,600 at the top because it's a combustion reaction.
But if you add
So
7,000,
this number here, any one of these can be negative, positive. It depends on the substance.
alright.
But this number here has to be negative. So what I was saying is, if you have negative 56 and negative 7860, you add this to this side, you get like positive 200, right?
Positive 2,000, and then
2,000, okay.
and then you have a negative
and then that
X,
equals
but
negative
then
X, and then divided by negative
I had a
1.
positive X, and then I had positive 5,000, so when I subtracted the 78, it made it a negative 2.
But I understand what you're saying. You're saying up here, you saw that as positive. They don't always say it's negative because it's a combustion reaction. The heat for the whole thing had to be negative anyways.
Okay.
So I'll just do that, and so next time it won't be confusing.
What's the units on the ending?
Kilojoules per mole. Okay, are we okay with this concept?
yeah.
so yeah.
Everybody kind of just seeing the little pieces? Because if I had asked you to solve, if I had given you all of these and asked you to solve for this, that's a pre-AP question, asking you to solve for the delta H. It makes it more of an AP level question when you're looking for one of these. Question.
How would it change part B if you were solving for gaseous H2O?
Okay, because if gaseous H2O, instead of it being negative 285.3, it would have been, since I opened.
Oh, it's
Like
at the chart value.
14, right?
Right, okay.
As a water as a liquid, water as a gas, negative 241.
Okay.
So the number would have been slightly different. Now, because they have to give you these numbers in the question, on an AP question, you're gonna use their numbers.
Okay.
On homework, when you're looking them up, you should be saying, well, would it be gas, would it be liquid? That's why I made this statement here.
All right.
So we'd all have the same answer,
Got it.
okay? All right, other questions?
No.
So,
This mo-
products minus reactants. Okay, I need for you to, turn in two things. Some of you have already turned in one or the other or both. You need to turn in those homework questions 1 through 8 that we did, like what, 1, 4, 6, 8, whatever, we did some of those. What?
I turned all that stuff.
I turned everything in.
Other than my, All right, back to computers.
So Joe, tomorrow, right?
Tomorrow.
You turned
Tomorrow,
in-
okay.
The black one.
We should
This
put
one.
this.
Do you want to make a video beforehand? When I record, what we think about, like, Android and all that? Like,
I don't
record it
think
over there?
beforehand.
What are you
I don't
recording?
think so.
Noah.
We're gonna trade phones.
Move away from the
Why?
computer.
Just
Wait,
try
you're
it.
gonna have his phone?
Yeah. He's gonna have mine.
Oh, that's gonna be awesome.
Things to do.
I'm gonna
Just
see
don't
if I
break
can
my
get
phone.
sold
These
on
are
it.
the two things
Just
I'm
don't break my
asking.
phone, please.
Guys, turn out. These are two things I'm asking if you haven't turned in or not. Okay? Some of you turned them in on Friday. So Chad, said you're 1 through 8. Will, you're 1 through 8. Chad, 1 through 8.
Your elbow is so pointy.
Do you have a case on it? Do you have any cases?
I have a cases for it, yeah.
Jose,
I'll give me a case. Because I don't want to break it anymore.
I'm not really worried about it. I'm gonna replace the screen when I get it back.
What?
I'm gonna replace the screen when I get it back.
Replace the screen
Yeah.
tonight so I can have a smooth experience.
Yeah, I was gonna do that. I don't have it yet.
Better because iPhones suck penis.
Well, I just want to see what it's like. I just want to see the smoothness.
okay,
No.
Everyone talks about it.
1, 2, 3, 4.
Mine is shooting video. Yours isn't doing anything. Yours isn't even